Hi, my name is John Dooley, and I am the entomologist for the United States Department of Agriculture, Plant Protection and Quarantine at San Francisco, California. My specialty is that I identify all of the whiteflies and armored scales that accompany shipments coming into the country from all over the world. Pull out your Fiorinia theae. Okay, if you go to couplet 2, shape elongate to oval, L1 lobes with medial margins diverging apically, sometimes forming a notch. If you look, it's a little harder to see on this. You notice that it's somewhat elongated. This one is actually pushed in a little bit, but the actual specimen on the screen, on the microscope, is actually a little more elongated. If you look at the pygidio, you can't see it here too well. Look at the pygidio area. You notice it's kind of V-shaped where the first lobe is. You can't see it here. It's pushed in a little bit. But you see it's kind of scooped in a little bit. And the inner margin of the medium lobe is actually more, is longer than the outer margin, which is very close to the margin of the pygidium itself. On this particular genus, and we're talking about couplet 2, the second part of it, the shape elongate to oval. You'll notice that the shape is fairly elongate, but a little more compact as compared to what we saw with Lepidosaphies. This particular one, there's two ways in which to go to the genus and the species on this particular specimen. Looking at the pygidium, which is over, you'll see that it is inverted. It's divergent, actually, and that's typical of several groups. And second, and this is actually, this is so compact, so some of these would look oval, some would look elongate. But Paravolar pores range from 0 to 5 clusters as well. If you look in your plates, plate 3, plate 4, and plate 5, quite a few diagrams. This would lead you to, if it's elongate to oval, and the reason why oval is Pseudalocaspis, the next group, which is Pseudalocaspis and Fiorinia, this leads you to. Pseudalocaspis, I'll show you later, actually has two different forms depending on the species. And they could be very fusiform and elongate, or they could be pear-shaped. So that's also an important factor. So you go to number 3, tubular process between the antenna, as I mentioned before. On this particular one, you have this tubular process, and this will give you the species, which is Fiorinia theae. These are the antennae, which are very interesting. They're usually like tubercles with one seede coming out of them. And that's also very important on that. And then if you go, and this is another character that's very important, and it's going to be hard to see. It says, for Fiorinia, well, there's paravolar pores in 5 clusters. The clusters, you could barely see them over in here. You could probably see them a little better right above the anal pore, which is right here. Just go right above this structure, this opening here. And you can see them as they run across, as they focus them in and out. So those also are paravolar pores. The other issue, it says, other character they're talking about, the marginal pygidial macroducts are small. They call them macroducts, but these are so small. They're very small structures right in here. I'll see if I can bring this. Yeah, here they are. You have to really put on high power. You see these are double barred structures right at the orifice, and the very thin tubes going to the margin. And in this particular one, you have, I think, 3 on each side. And they're called macroducts, but they're actually pretty small. So you need high power on those as well. So that will lead you, especially with that structure between the antenna, to Fiorinia tail.